Volume of a sphere pertains to volume of a ball, basically. How much air is inside your ball? How much ice is inside your snowball that you're going to throw when you're in Flagstaff? So that's what we're going to look at today, is the volume of a sphere and a hemisphere. And we can see the different formulas for the four types of 3D figures we've seen so far. Prism and pyramid are polyhedra. Cylinder and cone are not polyhedra because they have circles, but they are still a three-dimensional shape. So a sphere, by definition, is the set of points equidistant from a given point in three-dimensional space. We know from previous lesson, if we have a given point and we go equidistant around that given point, we get a circle. That's flat on the paper. That's two-dimensional. That's the best we can do. We need a ball. We need it to be three-dimensional. So that means that it has to go from a central point not only around this direction, but it has to go this direction and this direction. So that's why it says equidistant in a three-dimensional space. So there is our sphere. Basically, there's planet Earth. And we want to find the volume of planet Earth. So there's a couple of parts we need to talk about first. The equator of the Earth, which can be seen in this picture right here, is called the Great Circle. It's the largest circle you could draw on the planet. Don't confuse it with the Great Pumpkin. They seem to be related, but not exactly. The radius of the Great Circle is actually the radius of the sphere as well, because remember, the definition is it's equidistant in a three-dimensional space. So then the question becomes, well, what is that thing? I mean, it's really hard to see in a two-dimensional picture what is going on in a three-dimensional picture. So let me try to explain it to you. So let's say we're in Arizona. So we're about here. We're in Arizona. Maybe a little lower. We're in Arizona. And we want to dig to Australia. We're not going to fly, so we're not going to come around the curvature of the Earth. We're going to dig from Arizona down through the Earth to Australia. That segment that connects Arizona to Australia, so remember it's going inside, so you can't really see it, that segment is called a chord of the sphere. So the chord of the sphere actually goes through the planet. And so maybe I should probably have had that dash because you can't really see it. It goes through the planet. So now we're going to talk about the volume of the sphere. All we have is a radius, and we need it to be three-dimensional. So our radius is going to be cubed. So the volume of a sphere is 4/3 pi times radius cubed. So you can see the circle, pi r squared's right there within that circle. And then there's some kind of math magic going on as to how they get 4/3 pi r cubed. And that's not a good proof. It's not even a legitimate proof. But if you think about it this way, how do I remember if it's pi r squared or pi r cubed? Remember, we want it to be three-dimensional, and the radius is all we have, so we're going to cube it. Again, this is not a legitimate proof. It just helps you kind of remember the formula. Now, an interesting side note is if you've seen the newest Star Trek, the one with Chris Pine, it's a couple of years old, might be maybe 6 years old, 7 years old. At the very beginning of the movie, Spock is kind of down in this well, and he's taking his classes, reciting different things. And one of the things he recites is the volume of a sphere. So if you're watching that movie while you're on lockdown, check it out. See that little spot entertain yourself with the whole movie. So we're going to look at the volume of this sphere, and the first thing we notice is it's the diameter. The formula requires the radius, so we need to make sure we cut the diameter in half and get our radius. Volume of a sphere is 4/3 pi times radius cubed. So we're going to do 4/3 pi times 6½ cubed. So there's a couple of different ways we can do the 4/3. We can multiply by 4 somewhere and divide by 3 somewhere, or we can start here. 4 divided by 3 times pi times 6.3 cubed. So calculator strokes, that would look like this. And so the question becomes, well, how do you cube? So let's look at our calculator. Some of you are going to be lucky enough that you have not only a squared button, but you have a cube button as well. I do not have a cube button, so I do not get that benefit. But I do have a cube button in hiding. So the button y to the x is used anytime you have an exponent of any kind, and it lets you change based on the question. So mine's a cube. So I'm going to put in 6½, and then I'm going to push the button that says, okay, look, you can give it an exponent, and then remember I want a cubed exponent. So what that looks like all by itself would be 6½, and then I push my y to the x button, and then I tell it that I want it to be cubed. And that's the number I get. So I could, since I did that first, I could go ahead and multiply by pi. I could go ahead and multiply by 4 because it's a numerator, and then somewhere along the line I need to divide by 3 because it's a denominator. So that gives me approximately 1,150.35 meters cubed. Again, you can just start on the left and go to the right. You could do 4 divided by 3 times pi times 6½ to the power of 3. I get the same answer. Remember that you don't have to do pi at all. You could do 3.14 if you are so inclined. And you get a slightly different answer. You get 1,149.76 meters cubed. Now these differences are going to be a little bigger because the only value you have happens to be a number you're cubing, so it is going to affect the difference between a pi answer and a 3.14. Volume equals 4/3 pi r cubed. Again, we need to know the radius. Luckily, we know the radius. It's 12. So I'm going to do this one more time so you can see it. I started with the 4 divided by 3 times pi times 12. Now what if I don't have the cube button? Then I could do times 12 again, times 12 again. It still works. So it's approximately 7,238.23 cubed. So one more time, 4 divided by 3 times, let's say 3.14 this time, times 12, there's my power button, an exponent of 3, and so for 3.14, I get 7,234.56 centimeters cubed. So now, let's talk about what happens when we're filling a bowl instead of a ball. So if you think about this again as planet Earth, and this is the equator. Arizona is in the northern hemisphere, and Australia is in the southern hemisphere. So that's what it would look like, just the hemisphere. So you can see that the hemisphere has a circle, and then it's bubbled up here. So the radius of the great circle is the radius for the entire hemisphere. A hemisphere is half of a sphere, so it's half of 4/3 pi r cubed. Well, I don't want to write that all the time, and I notice that the 2 goes into the 4 twice. So I'm going to write 2/3 pi r cubed instead of having to constantly reduce that. Just like our first example on the sphere page, we are being given a diameter, so I'm going to need to cut that in half. So 12½ cut in half is 6.25, or 6 1/4. So our radius is 6 1/4. Volume of a hemisphere is 2/3 pi times radius cubed. So that's 2/3 times pi times 6 1/4 cubed. In the sphere we did 4 divided by 3. In the hemisphere we're going to do 2 divided by 3. So 2 divided by 3 times pi times 6 1/4 with an exponent of 3 equals. So that's about 511.33. And that's meters cubed. If you don't have the pi button, it's about 511.07 meters cubed. Not as big of a difference as the previous example because the number is smaller. And our last example, 2/3 times pi times radius cubed, because it's again a hemisphere. So our radius is 10, so 2/3 times pi times 10 cubed. So we're going to cube our 10, we're going to have around 1,000 times 2 divided by 3, and oh yeah, don't get multiplied by. So we get 2,094.40 meters cubed. If you don't have the pi key, you get 2,093.33 meters cubed.